And welcome back. So we just got done talking about the law of sines, and that's where the problems that were presenting to us gave us parts of a triangle, such as an angle and two sides, or one angle, a side, and another angle. And we were able to use the law of sines to find the remaining parts. Well, what about the other types of situations that come up? What happens if I don't have any angles at all? What if they give me all three sides? Is it possible for me to find the three other angles? Or what if I was given an angle, a side, an angle, and another side instead of the angle, side, angle? What if I was given a side, an angle, and a side? Could I find the other pieces? And the question is, or the answer is yes. And what they did to find all this was they used the law of cosines. Okay, and so what is the law of cosines? The law of cosines is used, in two cases. Now it says case 3 and case 4. That's because it was continue on from cases 1 and 2 for law of sines. But case 3 is the, hey, when I have a side, an angle, and a side, I'm going to use the law of cosines. When I am given three sides and I want to find somewhere else about the triangle, I can use the law of cosines. And the law of cosines looks complicated. It's not horrible. Okay? If you look, it's very loosely, it looks like it's based off of a squared plus b squared equals c squared, with a little bit more fudging around with this extra piece here. Okay? So the way that I memorize this is that whatever side you want, c squared, is going to be equal to a squared plus b squared, the other two that are left over, minus 2 times the two other sides that were left over, times cosine of the angle opposite the side that you're looking for. Alright, so let's see what we got going on. And that's true for all my cases. That's the best way to try and memorize this. Now, you will be given these formulas, so you do not have to memorize them along with law of sines, but you do need to know how this is set up. Alright, and just if you did not recall, this is the given triangle. All my sides are labeled A, B, and C. Little a, little b, and little c. My angles is where the capital A is across from. This will be capital C. This is capital B. Alright, so let's go ahead and take a look at some problems. Okay, that's all words. So here's some problems. It says solve this triangle. Again, remember, solve means I need to find the other pieces. So first, let's go talk about what pieces we need. I need to find angle A. I need to find angle B. And I need to find side C. And there's my triangle there that I've been given. I wrote it out. So we have to think about how do we want to go about this. Well, obviously this is the law of sines, right? And so let's do the one where I kind of explained it earlier. Was I want this side. So since I want that side, I'm going to start off by grabbing the one that's that formula, which is c squared is equal to a squared plus b squared minus 2 times a times b times cosine of big C. And then I just go through the process of filling in and using my calculator. So in this case, this would be 2 squared plus 3 squared minus 2 times 3 times cosine of 60 degrees. And that's going to equal c squared. And then you break out the calculator and find out what the answer is. And the answer is 7. But wait, I get all that 7. But then I have to remember, oh, yeah. Remember, this is c squared. Not just c. I want to get the, undo the squaring part, which is the square root. So that is something you cannot forget. So c is equal to square root of 7. So now what about an angle? The other angle, b. Okay, so here we are, square root of 7. So what about, let's choose an angle. You can choose A or B. I'm going to choose B. So again, I go grab a formula that has big B in it. And that's going to be the one where it says b squared is equal to a squared plus c squared minus 2 times a times c times cosine of big B. All right, and then I plug in with what I know. I know that b is, so this is 3 squared is equal to 2 squared plus square root of 7 squared minus 2 times 2 times square root of 7 cosine of b. And I solve for cosine of b. So what does that mean? Subtracting the 2 squares, subtracting the square root of 7, dividing by a negative 2 times square root of 7. Do all that and find out what cosine of b is. I'm going to grab my handy dandy calculator, find out what that is, and find out that the answer that I was looking for is 0.1889 is going to be equal to cosine of b. Again, what do? I don't want cosine of b, I want b. So how do I undo cosine? Inverse cosine. So I need to make sure that I'm able to do this. 0.1889 is equal to b, which is then equal to, get the handy dandy calculator, 0.89. And so the question then becomes, well, great, I got 100.89 here. How can I find out what A is? What is A? I wonder how I can do that. Oh yeah, they all add up to 180. So if I take 180 and subtract out the 100.89, and then I subtract out the other 60 that I had to begin with, I will find out that A is 19.01 degrees. Okay. So really, for solving these triangles, you got to use the law of cosines twice. You got to use some algebra first time, some inverse trig the second time, and then some simple math. Okay. So here we go. Let's do the next one. See what the next one's like. Oh my goodness. Here they go. They give us just 3 sides. No angles at all. Well, what do? Law of cosines, right? 3 sides. Law of cosines is kind of what this lecture's about. So, well, let's pick a letter. B. I heard B. Somebody said B. Either that or it was the buzzing in my ear. Okay. And I come over here and I say, well, we're going to get the one that involves B. That's the B squared is equal to C squared. A squared plus C squared minus 2AC times cosine of B. I plug in with what I got. So this is 3 squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of B. So I have 43, so I have a negative 43 over here is equal to a negative 48 cosine of B. And I go get my handy dandy calculator from here because I guess it'll be a little bit too complicated. I'll be right back. And so my calculator told me that negative 43 divided by negative 48 is 0.895. And that's going to equal cosine of B. Again, I need to undo the cosine, which means I need to do the inverse cosine. And I find out that 26.384 degrees is equal to B. Great. And guess what? I'm going to repeat the same thing for, I don't know, pick a letter. I heard A. So I want you to do the same thing for A. So what's going to happen? I'll help you out here. I'll put the, the formula. If I want A, and now I'm looking for A. So I'm going to have a squared is equal to b squared plus c squared minus 2bc times cosine of a. So now I want you to do the rest from here. All right, get up to where it's cosine of a. You should be able to do that without my help. All right, and I'll put the answer up here and see what we get. Pause the video right now, guys. Pause, 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 and boom. You should have been able to get 0.8889. Okay, is equal to cosine of a. All right, 27.266 degrees. And last but not least, I go ahead and find out what c is by taking the 180 minus 26.384 minus the 27.266, and I find out that c, I'll write that down, c is going to be equal to 126.349 degrees. And this is where we have to stop and check ourselves. See, did our answers make sense? And again, you got to remember that rule. Smallest side across from the smallest angle, largest side across from the largest angle. So my largest side was 6, which is across from C. So is angle C my largest angle? You betcha. Then I go take a look. My smallest side was 3, which is across from B. Is B my smallest angle? Barely, but yes it is. And that's true. And those are my angles. And it looks good. Amazing, right? I think it's kind of amazing. So you can find this, and then you're given 3 sides. You're given told that it is a triangle. And bada bing. You can find the angles. How cool is that, right? How cool is that? Let's find the next thing. Alright. So now we get into like the hardcore stuff. How is this used, or how can I find this? So it's called navigation is what we're going to be talking about. So we're going to talk a little bit about the degrees. And so we're going to be given this. This is a motorized sailboat leaves Naples. Is bound for Key West 150 miles away. So I know if I go straight here from Naples to Key West, it's 150 miles. Sounds good. Maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents, the crew finds out after 4 hours, the sailboat is off course by 20 degrees. So what does that mean? 4 hours later, going my 15 miles an hour means I went 60 miles and ended up going in the way wrong direction. So much so that this was off by 20 degrees. And so first one says is how far is the sailboat from Key West at this time? So if you take a look here they want to know this X right here. Hey, look at this. They're giving us a side, an angle, and a side. Side, an angle, and side. So do I use law of cosines, law of sines, side, angle, side, law of cosines is what I'm going to use. So when I do this, I go law of cosines, great. I have x, it's across from this 20. So this is where I say x squared is equal to 60 squared plus 150 squared minus 2 times 60 times 150 times cosine of my 20 degrees. And that's it. I will find out what that is. And I'm going to use my calculator right now to go ahead and find out what that is. And I'll pause here, but you won't notice it. See, you didn't even notice it. So when I was sitting there doing this, I come over here and I got an answer on my calculator of saying 9,185.53. And all of a sudden, I start thinking, I said, wow, I must be in a time warp because I only started 150 miles away. Now it's saying I'm 9,185 miles away. What's the deal? Ooh, that looks like it should be a 20. What's the deal? Oh, that's just x squared. Right, I got to take the square root of that, remember? When I take the square root of that, x is equal to 95.8411. That's better. Whew. All right. Okay. So that's how far I'm away now from there. So, through what angle should the sailboat turn to correct its course? Alright, so this is where it gets interesting. The angle I'm actually looking for, because I'm on this set line here, is I want to know this theta right here, the theta part, to be able to do that. But I don't, I can't figure out theta right away. What I can figure out is this angle A. Again, using the law of cosines for that second time that uses A. So that means that 150 is my A, or little a. So again, I grab the pieces I know. And I'm going to say 150 is my little a squared. Okay, is equal to, well, the other two, 150 squared, and then the other two sides, okay, which is 60 squared plus, and then the x squared that I just figured out, 95.841 squared minus 2 times the 60 times 95.841 times cosine of that A that I'm looking for. Again, I go ahead and grab my calculator, and my calculator is going to tell me. So I find out that negative 0.844 is equal to my cosine of A. Again, taking inverse cosine, I find out I get 147.636 degrees is equal to my A. Great. Am I done? Yeah. No. Again, I'm looking for theta. I wasn't looking for A, but I needed A to find theta. So how can I find theta? Well, what you can see is, hey, look, this is a big giant straight line. I want this theta right here. How can I do that? Well, I'm going to go ahead and I'm going to, let's see here. I don't know, it's a straight line. I guess there's 180 degrees in it. I can do 180 degrees minus that 147.636, and I find out that theta is equal to 32.363. And there we go, degrees. Whew, it's a lot of work, but I'm not quite done yet. Part C says how much time has been added to the trip because of this. Woo! Okay, well, how much has it been added? So assume that the speed remains at 15 miles an hour. Alright, so here's what you have to figure out. So how much was the trip supposed to take originally? Well, I'm 150 miles away. I'm going 15 miles an hour. Okay, my original trip, so I'm writing way up here, original, was supposed to take 10 hours. That was that 150 divided by 15. 10 hours. So let's add up how many total miles I now have now. So I went 60 originally, and I'm now going to go another 95.841. So 60 plus 95.841. Okay. And it's going to end up here going, and I add that up, is 155.84. So I'm going up 5.84 miles more. So I take the 5.84 and divide it by my 15 miles per hour to find out how many hours it takes me. And I find out it's 0.389 hours. And if I multiply that by 60, it will be about an extra 23 minutes. So this is equal to, again, 0.389 hours. I multiply that by 60 to get 23.36 minutes. And that's how much more time it took me. Okay? Wow. That's a great problem. And actually, I believe that's where I want to end it on for this lesson. The next time you listen to me, we're going to talk about bearings, I promise. All right, we'll see you guys when I see you. Bye.